Okay, the first exam was questions 1 through 10. We already did that part. Let me just scroll through that. And then the second exam, or we call the midterm, is 11 through 20. There'll be 5 multiple choice, and there'll be 5 open questions. So the first one is find the inverse of it, all right? Now, first thing I want to point out is f of x is equal to the square root 9 minus x squared, all right? They tell you the domain of it, and the domain of this thing over here is from minus 3 to 0, all right? If you want to draw a picture of that, you can. And one reason to draw the picture is so you see what it looks like. And that's going to be a quarter of a circle. It goes from minus 3 to 0, so it looks sort of like this over here. And we've done plenty of these in class, by the way. The point here is minus 3, comma 0, and the point here is going to be 0, comma 3. All right? What's its inverse going to look like? It's going to be a rotation about the line y equals x. And again, this is f of x. Its inverse, well, let's see. If I rotate the coordinate 0, 3, I would get 3, 0. And if I rotate the coordinate minus 3, 0, I would get 0, minus 3. And then when you get this over here, all right? That's my attempt at drawing the inverse. They didn't ask for it, but I did it anyway. What's the domain of that guy over here? Well, the domain of this is the inverse. The range of this guy, just looking at the picture, is going to be from 0 up to 3. Let's put the inverse down now. You get y equals the root of 9 minus x squared. Interchange x and y. X equals the root 9 minus y squared. What are you going to do now? I guess square both sides. What do you get? You get x squared equals 9 minus y squared. I'm going to try to solve for y, and that's going to be y squared. I'm adding y squared to both sides. I'm going to subtract x squared from both sides. And what do you get there? You get y equals plus or minus the root of 9 minus x squared. Again, I want to write this down, and certainly I'm not going to write that down. I'm going to write the inverse down now. What's the inverse going to be? Oops. Well, I'm looking at the picture. It's the negative portion of it. It's below the x-axis. So it's the root of this. Let me write the domain down for this. The domain is going to be, let's see, 0 to 3. And the range of this guy over here is going to be minus 3 to 0. Whoops, sorry about that. I'll put a little box in this and go to the next question. All right, again, it asks for the inverse. That's what the inverse is. The inverse is going to be the opposite of the root of 9 minus x squared. The domain is 0 to 3, including the endpoints, and the range is minus 3 to 0, including the endpoints. All right, this one, it says find the equation of a line through the origin. I want to put an equation of a line that's going to be y minus y1 equals m x minus x1. Now, if it goes to the origin, the point x1, comma y1 would be 0, 0. So I know that this is going to be y equals mx now. That's the equation. I certainly see a choice there, all mx. What I got to do is keep reading it. And they go on, it says it goes to the origin, but it also contains the radius of this circle over here. Well, let's write this down now. So it's a circle. It's x squared minus 2x plus y squared plus 2y equals 2. Half of the coefficient on those linear terms and squaring them, you're going to get plus 1, plus 1, plus 1, plus 1. What do you get over here? X minus 1 squared plus y plus 1 squared is equal to 4. This is a circle. Radius is equal to 2, and the center is going to be, let's see, 1 comma minus 1, all right? Now, by the way, they say that this line that we have over here contains the radius, so that much, it needs to contain the center. So then I can compute the slope now, and the slope is going to be, I got these 2 points over here, I was going to compute slope. So I'm going to say 1 minus 0, and then minus 1 minus 0, which would give you minus 1. So what do you have here? Y equals minus x. Do I see that answer being listed? I do. It's answer B. All right? Let's keep moving along. And as I do this, I want to go to the next question, and then next one. Now remember, if you take an exam, you can't answer a question, just go to the next question. All right? This one says, given these two functions, find the following. And these are going to be products and quotients. So the first thing I do is I got to do domain of f. Now let me just remind you how you do that. 1 minus x must be greater than or equal to 0, which means that x has to be less than or equal to 1. So I'm going to draw a picture of that, and the picture would look like you have the number 1. It could be equal to that, but x must be smaller than that number. That's a domain of it. Now let's put the g down, and as I do that, I'll put it over here, g of x. Well, to get the domain of that thing, x squared minus 4 must be greater than or equal to 0. Well, that's a quadratic inequality, so I have to solve it using the techniques we discussed in class. Put my two little zeros down. I'm going to say minus 2 and 2. I'm going to shade this in because it equals 0 there. And then take some test out. Like if you test out like a number after 2, like 5, plug it in, certainly be positive. All right? If you took a number between minus 2 and 2, like 0, and plugged it in, it would be negative. And if you took a number below minus 2, like minus 3, plugged it in, you'd get a negative times a negative, which is a positive. All right? So I know the domain of this thing over here. And if you want to write that down, you can. I'm not quite clear that that's going to be absolutely essential at this point. So what I'm going to do over here is I'm going to write this over here. And really, it's pretty easy. It's just simply going to be f times g, or g times f. Well, what's g? G is the root of x squared minus 4 times, and f is the root of 1 minus x. So I got that done. But it does say the domain. And what the domain is the intersection of these two sets. Now this is the number 1. So what I want to do is I want to draw that next to that and wonder where these things intersect. Well, the number 1's here, looking at the other guy. And it's below it, right? Where do they intersect? Well, let's write that down. From minus infinity all the way up to minus 2. Inclusive. This is the domain of it. Put a little box in that. Let's go to the next one. The next one says that you're dividing now. And it's going to be f, and this is going to be equal to, well, what's f? It's the root of 1 minus x. What's g? G is the root of x squared minus 4. Now, this is a little more tricky, but this is the thing they asked for. But they asked for a domain, so it's still the intersections, except those values that cause it a division by 0 on the bottom. So I'm going to say domain. It's really the same thing, by the way, but I have to exclude the minus 2, because if I included that, it would give me a division by 0. That's done. All right, 14 is a multiple choice, and multiple choice, I want to make a choice over here. And the first thing I want to do is I want to evaluate f of 2. This is f. F of 2 is going to be 3 times 4, because 2 squared is 4, plus 4, and that's going to be 16. Then what they want to do is they want me to do g of f of 2. Well, again, f of 2 is 16, so g of 16, well, what does g do? It's the square root of that number multiplied by 2. Well, the square root of 16 is 4, and then I add 5 to it. 2 times 4 is 8. 8 plus 5 is 13. Do I see that answer? I do. It's 13. Let's keep moving. And we're moving on to problem number 15 now. Now 15, again, reading it, it doesn't look that bad. It says if minus 4, 7 is a point in the graph of y equals h of t. Well, let me write this down over here. All right, I'm gonna put, I know there's a point, and what I have over here is I have a t, and on this thing I have an h of t. And I got the point minus 4, 7. All right, so I read that. I understand the table for that. Which of the following must be a point on a translated problem? So what I want to do is I want to put it down for you. So the translated problem, it's still going to be a t, but now it's going to be h of minus t. That doesn't look like a minus t. Let me go backwards. Minus 2. So, I got to give this thing what it wants, which, looking at this thing like the parent, that's got to be minus 4. So the only way to do that is put a 4 over here. All right, now I'm going to see if I can do that. And you're going to get, this is going to be equal to h of minus 4 minus 2. Well, why do I h of minus 4? It is. It's 7. So I'd get 7 minus 2, which would give me 5. So I'm looking around for the answer. Do I see it listed? And I do. It's C, 4, 5. All right, let's go to the next one. The next one says solve that inequality. This is a rational inequality, so I'll write it down for you. 3x minus 5, x plus 2, minus 2. But I need to build this because I need the same denominator. So x plus 2, x plus 2, greater than or equal to 0. Common denominator, x plus 2. What do you get in the numerator? You get 3x minus 2x, which is x, minus 5 minus 4, which is minus 9. Put the number line down. On the number line, I put down the zeros for the top and the bottom. One of the zeros on top is 9. The other 0 on bottom is minus 2. Now granted, the 9 makes it 0, but the minus 2 is undefined, so do not shade that in. You need to take a test point. After 9, take 10. You get positive over positive, which is a positive number. That gets shaded in. Take a number between minus 2 and 9, like 0, plug it in. Negative over positive, which is negative. Well, that's not greater than 0. I wouldn't shade that in. Take a number below minus 2, like, I don't know, minus 3. Plug it in. You get negative over negative, which is a positive, which is certainly greater than 0. So I'm ready to write my answer down now. I'll put a box on it. Minus infinity up to minus 2, not touching it. Union 9, touching it, off to infinity. And I'll put a box in this. All right, let's keep going. Next question, we're at 17 now. And again, as you go through an exam, if you have trouble doing the exam, skip the question. Like you look at someone and say, it's too complicated for me, skip the question, all right? Now this one over says, which of the following equations determines y as a function of x? Well, I'm kind of looking at it, and we have, generalized statements. We could graph them out, but I don't think it's a good idea to graph it out. Question is, can you solve this thing for y? And you could, all right? So I'm going to say, this one's a function. You could solve that for y. Could you solve this for y? Yes, you could solve that for y. All right, let me get my eraser out and just put check marks next to them. So determine which of the following equations is a function. This is a function. You could solve that for y. You could solve that for y. Unfortunately, this one over here, if I look at it, if I try to solve for y, you would get 2x minus 7 equals, when I say solve for y, I mean uniquely solve for y. And that would be y squared. If you did that, y would equal plus or minus. This is not unique. All right, there's two different answers. So this one's out of the question, right? Now, could I solve this one for y? Well, let's take a look at it. Yeah, I could solve that for y too. So I'm going to say this one's a function, this one's a function, that one's a function. Let's see if we see those answers being listed, by the way. And I'm looking for 1, 2, and 4. And I see 1, 2, and 4 in choice C. Okay, let's go to the next question. This is a composition. It's more difficult. And what I got to do over here is, the domain range of it. So I'm going to write f of x down first. And this is going to be the root 5 minus x. I'm going to put the domain down for this guy over here first. That's going to be when 5 minus x is greater than or equal to 0, which means this over here, that x is less than or equal to 5. If you want to graph that out, you can. I'll put the 5 over here. Could be equal to 5. And then it says it's less than it. So the domain of this thing over here goes from minus infinity up to and including the number 5. All right? The range of this guy over here, and it's a principal root problem, by the way, so it's going to be positive numbers. So it's going to go from 0 off to infinity. All right? And I'm going to do now g, and g's a quadratic. It's not a bad problem to do. It's going to be x squared plus 4x, all right? The domain of this is rather simple. It's going to be all the real numbers. There's no troubles there. There's no even roots, and there's no divisions. And the range of this thing, it's a parabola. It's a smiley face. Looks like this over here. And you would need to know the vertex of that. And I'm going to do that by just looking at the factorization of it. It's x, and then x plus 4. So the vertex would be dead center between the intercepts. Intercepts there are 0 minus 4, so it's going to be at minus 2. Now, what does this thing evaluate to at minus 2? It evaluates to minus 4. Let me just check that. So minus 2 plus 4 is 2, and 2 times minus 2 is minus 4. So the range of this guy over here, just looking at it, it starts at minus 4, and then it goes up to infinity. All right? This is the preliminary stuff. Now, when I do the preliminary stuff, it might be difficult for you, but you try. And this one is going to be f of g of x. That equals f of, what's g? Well, I'm reading it. It's x squared plus 4x. And what happens over here? Well, I'm looking at it, and what does it do? What does f do? It takes the root of it. And it's going to be 5 minus the argument. So I'm going to say, I'm going to write an order, by the way, minus 4x minus x squared. Now, a lot of students have trouble with the domain. This is the gatekeeper, by the way. Who does g let in? Right? Who does g let in? Now, someone says, I don't know who g lets in. I'll take a look at it. And g lets in, let's take a look at that. G lets in, where's g? Did I do that right? Yeah, g. Where's g? Oh, g's right over here. G lets in minus infinity to infinity. But then g tries to give f something. And what does he try to give? He tries to give minus 4 to infinity to f. Now, the bottom line is you're looking at f, and I hope you realize that that's not good, all right? So someone says, what do you have to do now? I have to restrict it, all right? So I'm really restricting this guy's domain over here. And again, if this is over your head, I would say let it go. But I'm going to write this down. So I'm going to say g is what? X squared plus 4x. And I'm looking at this thing, and minus 4 to infinity is not what I want. I want this thing to be less than or equal to 5. Now, why is that? If you looked at f, I'm looking at this over here. I know that this is what it has to be, by the way. Now, can I solve this over here? I think I can. So x squared plus 4x minus 5 less than or equal to 0. I'm going to factor it out now. It's going to be x less than or equal to 0. I get 5 and 1. And then I get, let's see, plus 5 minus 1. Put a number line down. I'm going to put the minus 5 over here, a 1 there. I'm going to shade those in. And then I'm going to say, what happens, after 1, you plug it in. That would give you, that would give you a positive number, by the way. That's not good. If you go between minus 5 and 1, you get 0. What do you get there? You get a negative number. That looks good. If you go below minus 5, like minus 6, you get negative times negative, positive number. So now I have my domain over here. The domain of this guy over here is going to be what just shaded in over there. So minus 5 up to and including the number 1. All right? So we got the domain of it. They did ask for that, and we got this part over here. All right, let's do the next one. All right, it's number 18, by the way. It's going to be g of f of x. G, what's f? It's the root of 5 minus x squared. All right, let's keep going. What does g do to the argument? It squares it. Now, if you square that, you would get 5 minus x squared. And then what does it do? I'm looking at g, by the way. It adds 4 times that argument, which is this over here. All right, so this is done. Not much I can do about that. And the next question is, can I get the domain of it? Well, the gatekeeper is this guy over here. And who does f let in? And I'm looking at it, and f lets in, let's see, minus infinity up to 5. And what does he pump out? He pumps out 0 to infinity. The question is, can G accept that? Well, G can accept anything. So the domain stands. And what's the domain going to be? Minus infinity up to 5. All right? So there's 2 questions, 2 answers. Let's see. I probably should put point values down for that. I forgot to do that. Each question were 10 points, by the way. So 5 and 5. All right? Let's go to 19. And let me just look back over this again, make sure I've answered those questions over here. And let me see. Yeah, I put in correct order. That's okay by me. And let me see if I put this in sort of correct order over here. And I got to make sure I did that right. You know, I think I copied something wrong over here. I did. I just noticed it. Let me move my eraser out. I want to be careful when I'm looking back over my work. And someone says, why is that? A lot of times you're not even thinking about what you write down. F is not 5 minus x squared. This thing can be erased over here. Sorry about that. And this needs to be erased as well. It's good to look back over. I want to look at it again, by the way, make sure I'm doing okay. And I did that. Yep, I'm going to get the next question. This is number 19 now, and 19 is an inequality, and that's a quadratic inequality. So I'm going to write it down, and the way I do that is I'm going to expand it first. So x squared minus 2x plus 1 greater than 1. Subtract 1 from both sides, and I get this. I factor it, I'll get this. Put a number line down. And a number line I can put numbers. What numbers do I put down? The number 0, because one of the factors becomes 0 there, and the other one's going to be at 2. All right? Now what I got to do now is I got to test the intervals out. And like if I go between 0 and 2, I'd pick 1, and I get positive times negative, so I would not shade that in. Now if I go after 2 and I take 3, I get positive times positive, I would definitely shade that in. Now if I take a number below 0, like minus 1, I get negative times negative, which is also a positive. I shade that in. All right, so I'm ready to answer it. I'll tell you what the answer is going to be. X is going to be less than 0, or the x is going to be greater than 2. Let's see if I see that answer, by the way. And certainly I know C, D, and E are out of the question at this point. So I'm looking at the first one. That's letter A. That says, you know, I got x. Well, no, that can't be right. Let's go to B, though. Let's see if B is right. So B says that x is less than 0. I do see that. Might be written a little differently, but it's still the same thing, by the way. I always read from the x less than 0, and x is greater than 2. So B is my answer. All right, let's go to 20. And 20 says, say, the domain and range of this guy over here. Again, if you want to expand it, you can, but I do know this is a parabola, and the parabola is a smiley face. I'll take this over here. And I know the vertex just looking at the equation. But let's say you didn't do that. You could expand it. You still get the same vertex, by the way. The vertex is going to be 2, comma 5. All right? So the domain, to write that down, all real numbers. And the range of this, I also forgot to put point values down. All questions are worth 10 points. Well, I'm looking at it. It starts at 5, and it goes off to infinity. We are now done. There's nothing else. Hope you did well in the exam. Thank you. Bye-bye.